try out this activity. We're talking basically about the same rule we talked about last time. If I have 4 to the 5th squared, that means I have it twice. So that means I should be adding those. So is there a faster way instead of saying 5 plus 5? Well, that'd be 5 times 2. So this would be 4 to the 10th power. So as these powers get bigger on the outside, we definitely don't want to keep writing this over and over and over again. So this would be 6 plus 6 plus 6. So this is 6 times 3, or 3 to the 18th. Try the rest and see if you can predict and answer the question. Y to the 11th to the 33rd power. Alright, now that you're done with that activity, you see our rule is basically in algebra. If I have a base of a, m and n are powers. Of course, we want those to be integers right now. The base is not 0, so if I have power to a power, I should multiply those two numbers to get a product. So example, if I have base of 5, it's to the 4th power, and we're going to take that to the 2nd power. All we're really going to do is keep our base as 5 and do 4 times 2. Okay, and if we take care of 4 times 2, we're going to have 5 to the 8th power. Doesn't matter if we change the base to a variable, that's fine. So m to the 3rd, and we can take the 3rd power to the 5th power. So instead of writing that out 5 times, we're just going to multiply m to the 15th. So if we use that idea again, n to the 4th to the 7th, again here we're saying that I have two powers, so that's what we're talking about when we say power to a power. So 4 times 7, n to the 28th. Bottom half of our notes. Now if we want to find the area of a square, remember area of a square is the side squared. So they're telling me one side is 5x to the 3rd power, so I'm going to square that. Now we have to be very careful that that means we want 5 to the 1st power squared. So that means I need 1 times 2, so I have 5 squared, x to the 3rd power squared, so that's 3 times 2, so x to the 6th. Notice none of my answers have a power with 5 squared. So I know 5 squared is going to be 25, and then I'm looking for x to the 6th. So the correct answer should be D. Here we have a breakdown. Remember 5 is to the 1st power, so 5 squared, 1 times 2 is to the 2nd power. And if we have x to the 3rd squared, so to the 3rd squared. So each one can be done separately, just like we did over here. Alright, now if we run into multiple rules at one time, which is where we start to have a little bit of trouble, see that I have power to a power, so order of operations, that should be done first. So I have to take care of the green part first. So y, 5 times negative 2 is negative 10. And then I have to recall that old rule is if I have multiple bases that are the same, so here y is the base, they're the same thing, and 3 and negative 10, in this part of the rule, we have to add them. So 3 plus negative 10 is negative 7. So that would be my final answer. Alright, let's try and clean some of these up. If you think you have the idea here, I want you to pause it and then start to play it again to check your answers. Alright, so I have to take care of a power times a power first. So x squared times x to the negative 24th. So x to the negative 22nd. That's my final answer. So I have w to the negative 2nd. We're going to take that times w. This part is power to a power, so that's 21st. So 21 minus 2, w equals, or w to the 19th power. Here they change the order. So we're going to do power times a power, so r to the positive 10th, negative 5 times negative 2. We have to take that times r to the 3rd, so we get r to the 13th. Alright, as we throw a second part in there, remember this is 7 to the 1st power, this is 2 to the 1st power, z to the 1st power, this is 3 to the 1st power. So the rule is exactly the same. Power to a power we multiply, but keep in mind I have 7 as a base and m as a base. So I need 7 to the 3rd, m, and that's 9 times 3 to the 27th. I have 2 to the 1st to the negative 4th, so it's 2 to the negative 4th. I have z to the 1st to the negative 4th. So z to the negative 4th. We have 3 to the first, and that is to be taken to the negative second. So 1 times negative 2 is negative 2. And g, 4 times negative 2 is negative 8. Okay. Of course, we can go back and clean these up and use a calculator and get a value, right? 7 to the third power, 7 times 7 times 7. But right now I want to make sure we're getting this idea of multiplying powers and realize that 7 and m to the ninth are two different ones, and this third power has to go to both. Alright, now if we get a whole mess of stuff, same idea. Here I have power to a power, so I can do this first, n to the 10th. Here I have a power to a power for the 4, the m, and the n. So 4 is to the first, m is to the first. So I have 4 to the first to the third, so 1 times 3, so 4 to the third. M, 1 times 3, so m to the third. And n, negative 2 times 3 is negative 6. Then we have to use our old rule. I have 4 to the third, I have m to the third, n is to the 10th, and also to the negative 6th. I have multiple bases. So now it goes back to my old rule of adding. So 10 plus negative 6 is n to the 4th. Again, we can always clean up 4 to the third by doing 4 times 4 times 4, but right now my stress is that I want to make sure we take care of our rules in order. Last part we have to take care of is scientific notation to a power. So we're going to treat this just like as if it was 4x to the 5th, and we have to square it. So 4 has to be squared, so 4 squared is going to be 16, right? Because this is 1 times 2, so 4 squared is 16, 10 to the 5th, so times 10 to the 10th. 5 times 2 is 10. 16 is too big by one place, so we have 1.6 times 10 to the 11th. So that guy's taken care of. So same idea. So if it's in proper scientific notation, in this part it's always just going to be 1 times 5, right? 1 times 2. So we got 2 to the 5th power, which is 32. So times 10 to the negative 15th. So times 10 to the negative 15th. So it's 1 too big, so I have to add 1. So 3.2 times 10 to the negative 14th. Let's move this calculator out of the way a little bit. So we do have a little bit of space. Alright, 3.5 to the 1 times 3, so 3.5 to the third times 10. Here's the easy part, to the 14th, the 12th. 3.5, oh my goodness, 3.5 times 3.5, this old calculator here, times 3.5, and it equals, alright, so we got 42.875, alright, done with that calculator today, times 10 to the 12th, but we all know that this isn't going to work, so plus 1 here, 4.2875 times 10 to the 13th, and that looks like it's proper. Yep, that'll work. Alright, last part. Write 4 different expressions that are equivalent to x to the 4th to the 3rd. So basically what we're after is we know that this becomes x to the 12th. So how many different ways can we write that? So we know 1 is what we have, x to the 4th to the 3rd. 2, x to the 3rd to the 4th. That's a little bit cheating, but that's okay. 3. Alright, so I need the product, these two things being multiplied together to give me 12. So what else could we use? X squared to the 6th, right? 2 times 6. I could use x to the 6th to the 2nd. Okay, so that would be number 4. So they wanted 4. It doesn't say we have to follow today's rule. So could I write as a 5th option x to the 4th times x to the 8th? I could write x squared times x to the 3rd times x to the 4th. What are we up to now? 4, 7, 8, 9. 12 thirds, so that would work as well. So you get the idea that there are many, many different ways we could write this, just following all those rules. So we need to get a total of x to the 12th, and all 6 of these, even though you only had 4, will work. I just wanted to show you that idea. So what I'd like you to finish up before you come into class is what would all these blanks have to be? So if I have b to the second, our rule is to multiply, so 2 times what number gives me 8? You don't have to yell at me. I know it's 4. There you go. Alright, so keep in mind what the sign is. So if it has to become negative 12 and you're multiplying 3 times something, this has to be a negative number. Alright. Good luck. We'll take care of any questions in class.